Alright, like Mr. Murphy said, you guys are now masters at factoring and previous and everything, so we're going to move on to some plugging time stuff. It's really just like what you guys did is point slope, or you're given information how you're going to find which equation you want to plug it into, solve for a missing variable, and go from there. So, section 5.8, modeling with quadratic functions. Nice learning target for you guys, is I can write quadratic functions given characteristics of their graphs. So the first form here, I put them over here too, so we can reference them even when the slides are gone. The first one is vertex form. So in vertex form, you're given a vertex of a graph. You guys should know it's labeled here. That axis of symmetry of a parabola. And you're given a point in xy. So in the equation, the vertex equation, the points are given to you as h and k. And the points are given to you as x and y, just like normal. And then here's the equation. Y is equal to a x minus h squared plus k. And then we can do this one. So it gives you a vertex of 2, -3, and your point that you're given is 4, 1. And so you want to plug that into the equation. So what is the value for y? What would we look at? The vertex that's given or the point that's given to get a value of y? No? Alright, so you're given a vertex, h and k, and you're given a point that's labeled x and y. So here is your vertex, this is h, this is k, and here's your point, this is x, and this is y. So you have 4 values here. Your equation has 5 values, and you want to solve for the one value that you're not given, which is a. So now I want to take these 4 values that I have and plug them into the equation and solve for a. So first we're going to take y, which is 1. But now we're solving for a. And then you have x, which is 4, minus h, which is 2. All of that squared, plus that k value, which is -3. Does that make sense? Alright, now you're just going to solve for a. So the first thing that you want to do is do that inside of the parentheses or with operations there. So 1 is equal to a times 2, 4 minus 2 is 2, squared, and then plus -3 just gives you a -3. Alright, then we want to square that too. So 1 is equal to 4a minus 3. Let's add that 3 over to the other side so we can get a by itself. So then we have 4 is equal to 4a. Finally, a is equal to 1. But you're not done yet because they're asking you for an equation. So now you have your a value. All you have to do is put the a value back into the equation with the h and the k, so your vertex. And then that would be your answer. So for here, we're going to have y is equal to 1 x minus h, which is 2, squared plus k. K is -3, so -3. And there's the equation of this graph in vertex form. You guys get that? Any questions on that one? Okay. So now we're going to do the same thing, write a quadratic function in vertex form for the parabola shown. So step 1, look at the graph, see what it gives you. It wants it in vertex form. And if it wants vertex form, they're going to give you a vertex and a point. So it looks like this one did that. So first, I think it's easy if you just write what the vertex is off of the graph, so that you can keep track of them while you're doing it. So the vertex here is 2, -2, and the point is 0, 2. So your vertex is at H and K, and your point is your X and Y. And then you want to write down that vertex equation. Y is equal to a X minus H squared all plus K. Now just like that last one, we're going to plug in the four things that we have and solve for A. So Y is 2. We're solving for A. X is 0 minus H, which is 2, squared, and then again plus K, but K is negative 2, so it's going to be minus 2. 2 is equal to 0 minus 2, what's negative 2 squared? Huh? Good morning, what's negative 2 squared? 4. 4 minus 2, add that 2 over, and again you're going to get A is equal to 1. But are we done yet? No, we got to plug this back in. So Y is equal to 1. Do I have to write the 1, or is it okay if I just leave it nothing there? Yep, you can either write the 1 in the A spot if you like to, or you can leave it blank. It still means there's a 1 there. So I'm just not going to write it. So then it's X minus H, which is 0. So again, you wouldn't have to write the 0 there either. You could just do that plus negative 2. H is 2. Right? Yeah. Alright, you guys get that? Alright, now this one's a little bit tricky, maybe, because they don't give it to you in a graph, but they're still giving you a vertex and a point. So does anyone think they can come up and give us the equation? Okay.
This equation, you want me to
Plug it in. So here's your equation. So you're given the vertex. If it helps, you can mark.
just find the root of X and Y.
Yeah, but if it helps you, you can mark above the points that your vertex. Here's H and K, X and Y. That will help you keep it straight. So for A, you can use your classmates as help if you want. You give us the equation. Perfect. Nicely done. Thank you. Did everyone else get the same thing? Any questions on that one? All right. So the second form we're going to work with is intercept form. So very similar to vertex form. You're just given different. You're not given a vertex and a point, but instead you're given x-intercepts and a point. So just to review, x-intercepts is where the graph crosses that x-axis, or axis. Those are your zeros. So now you're given those 4 points, same thing again. You're just going to plug them in, still solve for A. It's just writing in intercept form instead of vertex form now for these parabolas. So for this one, we're given the x-intercepts are -2 and 3, and we're given that a point that the graph passes through is -1, comma 2. Now we're just gonna plug and chug again. So 2 is equal to a, which we're solving for, x, which is -1, minus -2, so +2, times the quantity x again, -1, minus q, which is -3. Be careful here, you might see two parentheses next to each other and want to start foiling that. Notice that there's no x's or variables in there at all. So don't be too good at factoring and start factoring when you don't need to factor. So 2 is equal to a times -1 plus 2, which is 1, and -1 minus 3, which is 4. So -4 times a. So a ends up equaling -1/2. And then again, you just want to write it back and plug that a back into your equation and give it with the x-intercepts included. So y is equal to -1/2 x minus p, so +2, x minus 3. Alright. So here we have, did you guys get it all down? Do you want me to go back? Yeah? Alright. So look at this one, we're giving, again, an x-intercept, and we're given a point that the graph passes through. So now that you know that you're given those, you want to look which equation are we going to want to use? Well, we're going to want to use the intercept form because that's the one that you use when you're given the x-intercept and a point. So your x-intercepts are -3 and 3, which I think it's helpful to label them P and Q so that you don't get confused when you're plugging them into the equation. And then your point is -1, -4, and that's your x, comma y. So then y, which is -4, is equal to a, which we're solving for, 1 minus -3, so +3 times 1 minus 3. One plus 3 is 4, so a times 4, 1 minus 3 is -2 times -2. A is equal to 1/2. Now again, just write that back into the original equation. Y is equal to 1/2 times the quantity x minus 3 minus -3, so +3, x minus 3. Any questions on this one? You guys get that down? Alright, last one here. Given x-intercepts and a point, real graph. Sum it up, yeah? Huh? Okay, so these are your x-intercepts here. If you look at where the origin of the graph is, it's right here at 0, 0. So it's kind of tricky because this parabola is shifted down quite a bit. That maybe you're thinking that the axes are different, but just try to find that origin and then where it's crossing that x. Remember, this is the x, it's labeled here. Here's the y labeled there. That makes sense.
Sometimes the pictures are hard to see on the smartphone. They have to be zeros.
All right, can I have a volunteer to come through this one? Someone different.
Sorry.
Someone, thank you.
Hey guys, also, I just remind you what I solved calculators in here. With the test coming up on Thursday, if you know that your calculator is like halfway charged or whatnot, wouldn't be a bad idea either today or tomorrow to throw it on. There's a charger on my computer that has to. You've got a couple of minutes just to throw it on a charger. The charger doesn't take long to throw it on. And if you are busy or whatever, in this drawer right here, there's usually a couple of extra cords if you needed to plug it into your Chromebook charger. Do that as well. I just know that with the test coming, I think you guys go, oh, my calculator's not charged.
All right, did everyone get an A value of -5 when they solved it on that? Yep. And then you just plug that back into the equation with your x-intercepts. And there's your equation. And then
Should be just normal five because yeah, negative. Okay, never mind.
yeah, there you go. Is this your slide?
Oh, no, sometimes if you hit the button, that one pops up. I don't know why. The menu comes up. Yeah. So, ladies and gentlemen, thank you. What happens when you think about the ways we've been doing our quadratics, we had the three forms. We had vertex, intercept, and what was the last form? Standard. Okay. Standard form was the one that, when we did it, you have to bear with me, this is really hurting. Your standard form was your ax squared plus bx plus c equals 0. And what you were doing with those is that you were able to get your axis of symmetry and opposite of b, or opposite of b over 2a, and so on and so on and so on. When you're given 3 points, and this is kind of the last ditch one that's there. When you had vertex form, obviously you had vertex and a point. When you had intercept form, you had your zeros, your intercepts, and then you had a point. Those guys, you basically had 5 variables. You were given 4. You solved for this guy. Procedural, over and over again. Kind of the same thing with the intercept, or I'm sorry, with the standard form, but there's one extra step that gets thrown at you. And it's not that it's complex. It's fairly simple. When you're looking at a standard form of the equation, a quadratic given 3 points, you're going to be given 3 sets of x's and y's. If you look at this then, we were trying to get them into this format. That means I'm going to wind up generating 3 separate equations. Okay? Excuse me. This is my x and y for the first one. It's my x and a y for the next one. This is an x and a y for the third. If I take those together, I'm trying to figure out what the coefficients A, B, and C right now, because I have my values of x and y. So what we do is we just kind of throw them into this formula, and I'll show you how this is going to work. If I start with the first set, I get A times negative 1 squared plus B times negative 1 plus C, and it has to equal 5. All I'm doing is substituting in directly x's and y's. You okay with that? I do it again with the next one. I have A times 0 squared plus B times 0 plus C, and that has to equal 3. Right. And then lastly, I do it with the third point. A times 3 squared plus B times 3 plus C is 9. What I'm doing here is I'm going to generate a system of equations. It's a 3 by 3, which means what buttons are we going to be pressing? Matrices. Okay, we're going to do some matrices. So as you go through it, what's negative 1 squared? What's negative 1 squared? 1. Okay. So I'm just going to rewrite over to here. I get 1a. The next one becomes negative b. So negative 1b. What's the coefficient in front of the c that we don't see? A 1. I'm going to put a 1 there then. Plus 1c, and it has to equal 5. What's 0 squared? What's that? Oh. Sorry. So we have 0a plus 0b plus 1c is 3. And then lastly, I get 9, 3, and 1. Be okay with that?
What?
What's 0 times 0? What? Go ahead. I'll show you. I'll show you. No, don't worry. Don't worry. Don't worry. This is another procedural style. There are 3 points which allow you to generate 3 equations. Okay? And if you remember when we did systems of equations not too long ago, we spent a day talking about how you can go longhand on 3 by 3 systems and solve them out. And I said that's just silly because we can use what's called a matrix. So what happens here is we generate what's called remember what I called this, a coefficient matrix? If I take the coefficients, what are my coefficients? 1, negative 1, 1. What are my next set of coefficients? 0, 0, 1. 9, 3, and 1. Remember how we put this in the calculator the other day? We would do the 3 by 3 inverse. Alpha window 5, I think? Alpha window 3, sorry. Thank you. And then what we did is we did the inverse of that multiplied by the oh, it's alpha zoom. Thank you. Alpha zoom. Alpha zoom. So let's see here. Alpha zoom. So if I kind of have to see what I'm typing. And then what we have? 1, negative 1, 1, 1. Make sure you use the negative symbol, not the minus symbol. Surprised. 0, 0, 1. And then 9, 3, 1. Thank you. Then, remember we used the inverse button that X is the -1? And then we created one more matrix, 3 rows, 1 column. Alpha zoom. And obviously, you guys are a lot faster typing this than I am because this is kind of slow. 5, 3, 1. 5, 9. 5, 3, 9. Thank you. There's your A, B, and C. If you have an error, you might have a minus sign. Is that what it was? So those values go in the order in which you put them in. A, B, C. So there's our A, B, and C in the column. So our answer then, 1, -1, and 3. 1, -1, 3. So this is A, this is B, and there's your C. The trick here is that sometimes when you guys go too fast, when you square a negative, you'll forget that it's positive. So your answer winds up being x squared minus x plus 3 equals 0. And there's the quadratic that contains those 3 points. The matrix solved what you solved for A, B, and C, and the matrix did it for you. You could have solved that system of equation by hand because you knew right away what C was. C was 3, and then you could have had a 2 by 2 matrix if you wanted, but not always will be that clean. Okay. There are multiple ways of doing it. I think that this is the one time that matrices are rather helpful. It fits in nicely with what we've been doing with the quadratic stuff. Okay. Let's walk through another one. Okay. You're all right. You're all right. Waiting. What do you mean? Oh, yeah, you could have put either one. I wouldn't yell at you because we're generating the equation that would have those points. If you put y equals, that's fine. If you did 0, then you would think you'd have to find zeros. Either one, I wouldn't yell at you. That's okay. Where's my other one? I'm sorry, guys. I'm really not trying to fall over. Same idea. Same idea here. We've got your 3 points. We're going to put it into standard form. And like this Yule was talking about earlier, how do you know which one that you're going to use? Well, if you have a point and a vertex, you're probably going to have to use vertex one, don't you think? If you're given a set of zeros, probably going to have to use the intercept form. And remember, terms generate zeros. So if you have a 0 at 5, that meant the term that generated that 0 had to be x minus 5. Remember how they interact with one another. And then lastly, if you're given 3 points, you have to use this method. That's the only way we'll be able to make it work. So again, as you go through, you're trying to get it in the format ax squared plus bx plus c is y. After a while of doing these things, you could probably jump right to the matrix if you'd like. If not, if you want to write it out to get all the coefficients correct, that's also just fine. I'm going to take a leap of faith that we can probably figure this out. What's -2 squared? 4. So I get 4, -2, and 1. Top tip. Guess what that last column is always going to be? The C. What's the coefficient of C always going to be? It's always going to be This last column will always be ones because we don't have anything to do with C. We know that the number in front of it is 1. What's 1 squared? 1. What's 2 squared? 4. Okay. Let's talk so I get it. There's your inverse matrix, and your answers have to equal -1, 11, 27. And it's calculated. It looks a lot worse than it really is. It's nice that today is, again, one of those very procedural steps. Do this step, do this step, do this step. As you're going back and you're looking back with what she was working with you guys with vertex and intercept, it does not hurt any at all to write out your formula and then just write the numbers that are going to go into it right above it or right below it so you know how everything's going to match up. Labeling parts are hugely important. You guys know how much I love doing that, labeling where all everything's going to go. It makes your life easier in the long run. Excuse me. I know you guys can press buttons a lot faster than I can. Senor. It means inverse. Anything to the -1 power is an inverse. It's an algebraic thing that we haven't quite gotten to yet. We kind of skirted the system by teaching you little shortcuts. Yeah. Anything to the -1 power means you flip it. So 2 to the -1 is 1/2. What's that? Within matrices operations, when you are trying to solve them, you find their inverse, and there's a whole procedure of doing that longhand by getting the determinant and then multiplying it out. And correct me if I'm wrong, to do a 3x3 would be about half a page per problem. Yeah. Yeah, it's about half a page of actual just multiplying, subtraction, and addition. It's awful. That's why I said, hey, guess what? There's a button. And I'm okay with it. Yeah. What'd you guys get for your solutions on that one? 3, 7, and 1? 3, 7, and 1, everybody agree? 3, 7, and 1. That means you have a 3x squared plus 7x plus 1 equals y. And that would be the stuff. Now, what's nice is that since you have this fancy calculator in front of you, couldn't I throw that into my y equals and make sure that those 3 points occur in the table? Because if they do, you're all right. If they don't, you're done goofed. Questions about any of those 3 methods here, guys? And there's a lot of procedural stuff today. The back half of this chapter is kind of like that. Yeah, I'm okay with you. I'm okay with you. What I wanted you guys to look at this evening is we're going to kind of do 2 of each of these. It's kind of the same thing after a while. And don't remember if I've already put the PDF file online off the top of my head, but I'll double check it here in a second. It's going to be on page 309. Let's do 12 and 14. 22 and 23. And 29 and 31. We'll do 2 of each style. I think 6 is okay with that because I also wanted, that way we can verify we did those things okay. Because I also wanted to get in your hands extra solve for factoring, solve for quadratic, solve for square. That way, if you have other questions with formula and stuff, we can knock that out first half of the day. And then we can spend our time revisiting some more of the word problem stuff. This is some of the review. I was saying, I would look at some of it, that way you get the idea of, is there a certain style that you need to work with, and so on. Like I was saying here, guys, this sheet, this one that I had here for you, it's just got some stuff that says, you know, solve by factoring, solve by taking the square roots, solve by the quadratic, solve by completing the square, discriminant, you know, things, just quick stuff. That way you have extra stuff to look at as far as practicing is concerned. There may or may not be imaginary numbers. I may or may not have a solution guide to that somewhere. Which basically means when I post that PDF, I will also post the solution manual to it. Well, not a manual, but just the answers at least. What happens sometimes with CUDA though, they have a tendency. Remember how sometimes they split fractions, and I don't normally split fractions. If you see that there's fractions are split and you've got something that's like all in one, you're fine because I rarely will split fractions on these things at all, if ever. We'll go from there. Sound decent? Excellent. Let me save this and make sure everything's posted.